Videos, we've looked at quadratic equations, and typically they are written as some number times x squared plus some number times x plus c, and usually they're seen as equaling 0, but it would be more accurate to write that it equals f of x, or it equals y. That means the same exact thing, right? ax squared plus bx plus c, because these x values equal some y value, and that's what f of x is all about. It's a function that says, well, you plug x values in here, and then this side is going to be the function of whatever you plug in. So it's just saying that this value depends on the x's you choose to plug in, which is exactly what y represents as well. So it doesn't have to equal 0. But again, if you let y or f of x equal 0, we could factor our quadratic sometimes, and then we can solve for x. But in this video, we're going to look at the, I guess, almost famous, maybe infamous quadratic formula. And it's really fun to prove the quadratic formula, and really important, because otherwise we start to memorize this huge formula without thinking about it, and that's not a good thing to do. But we are going to go over in this video how to use this formula. So the quadratic formula says, okay, if you have something ax squared plus bx plus c, and you have it equal to 0, so if you can get it in that form, there is a way to solve for x without factoring. And that is that x will always equal, and it's just really cool because we taken x squared and x and found a way to rewrite it as x equals negative b plus or minus, and this is a beefy formula, the square root of b squared minus 4ac all over 2a. And a couple of things in terms of terminology. That's right, I said in terms of terminology. This is called the discriminant. And there's some properties that we can memorize of the discriminant, but some of them are just really wonderful logical ideas. For example, if this is 0, well, then you've only got one answer. And if it's negative, then you don't have any real answers, which we can talk about in other videos. But another thing we should look at here is this plus over minus idea. That means that we have two answers. So it means plus and minus. So x is going to have two values, and that's also logical because if you go back to what a quadratic looks like, right, something like this. So for every y value we pick, let's say y up here is like 2. Well, look, there's an x value over in this direction and an x value in that direction. There's two x values for that y value, and that's what we're showing right here. There's two values at this x, right? So, and that's when we're at 0. So what does this look like, and how do we do this? Well, really all you need to know is the value of a, b, and c to solve the quadratic formula. So let's start with, let's just make something up here. 3x squared plus 11x plus 5 equals f of x. So this is our quadratic formula, and in the past, our quadratic equation. Now in the past we've said what factors of 5, right, the factors of the constant that add up to, so factors of the constant that add up to our coefficient, that add up to our coefficient of 11. Or a faster way of saying that is the factors of c that add up to, so the factors of our c value that add up to our b value. Well, the factors of 5 are 1 and 5, or negative 1 and negative 5, neither of which add up to 11. So we can't factor. And in fact, what we might want to think of in this case is the quadratic formula. And that's when the quadratic formula is super useful. We don't have to worry about factoring. We can just figure out what's our a value, what's our b value, and what's our c value, and then plug it into the quadratic formula. So in this case, a is 3. It's the number, the coefficient next to x squared. b is 11, and c is 5. So our quadratic formula, x equals minus b, so minus 11, plus or minus b squared, so 11 squared, minus 4ac. That means 4 times a, or 3, and then times c, or 5, all over 2 times a, or 2 times 3. So x is equal to negative 11 plus or minus, put a denominator is 2 times 3, nice and easy, that's 6. 11 squared, that's 121. 4 times 3 times 5. Well, 4 times 3 is 12. 12 times 5 is 60, so it's 121 minus 60. And that is equal to negative 11 plus or minus the square root of 61 all over 6. The square root of 61, well, 8 times 8 is 64, and 7 times 7 is 49. So it's not a perfect square, it has no exact root, it's irrational, and since we're making this problem up, let's leave it in terms of the square root. I don't want to have to round or estimate. We could do that, but let's just leave it like this to get the idea of how the formula works and how the answers work. Here, x will equal two things. In the first case, it'll equal negative 11 plus the square root of 61 over 6. And in the other case, x will equal negative 11 minus the square root of 61 over 6. Now, we might look at these examples in other videos just to get more practice, but when you get these two answers, if you need to figure out which one's correct, or if you're not sure if one of them is correct, you take the value and plug it into your equation to see if it works. So in other words, if I plug this into this equation for my x values, will I get 0? And for both of these, fairly certain at least, that you will get 0 and they will work. But maybe we'll test those out in a later video. The basic idea is that we have a quadratic formula, and all you need to know is what a, b, and c are to plug in and get your value for x.